a repository called Python Polylith example. You'll find it here. And in this repo, you will find an example setup of how to use the Polylith architecture with Python. So you can read a little bit about it here, but I'm going to demo the code. So I have pulled the repository to my computer. And what we see here is we have a basic Polylith structure here, a Python version of it. So we have bases, components, the development folder, I'll come back to that later, and a folder with projects. So let's have a look at that one. So this demo repository has two projects, one creating an AWS Lambda, and another project that will create a fast API project. So, and if we have a look at this folder, you will see that there is no Python code here. This is only infrastructure. So this is where we define the project, the artifact, what we want to build. So I have a project PyProject TOML file here, defining which components to add, Python versions, and things like that. And in this project, I thought it was a good idea to create a Docker file to deploy it in Docker. So I've added a Docker file that will grab a built version of this project, install it in the Docker image, and when all of the installation is done, it's going to start it just as you would start a fast API, in the way you would start a fast API app. So what's this? So this is a built wheel, and this is because I think this is a good idea, because since you have a project with code that is spread out in a repository, you pick your code from components and bases. So instead of manually copying in code from here, I would recommend to create a package for a wheel or a source distribution based from this pyprojects.toml file. And that is possible. Currently, I'm using Poetry, and Poetry has a limitation that means that it won't allow relative includes. But with the help from the multi-project plugin, we can now do that. So I'm going to start off by just building this fast API project. Like this. So I'm in the project folder, and I can run this command, Poetry build project. So what happens now is, if we see what's added, we have now a distribution folder, a dist folder. And that folder has a wheel and a source distribution. So it's that, if we go back to the Docker file, so this is the file that is actually copied into the image. So if we have a quick look at the wheel file, you see that all the files are actually put in the wheel. So we have built a local project based from the components and bases, like over here. So this means that you won't need to do any manual copying or look up what kind of what kind of code is used in this project, or maybe you would even copy the entire source code, and that's not necessary when you can build it like this. I think I'm going to continue actually running this code just to see how well it works. So I did this step, run build project, and I'm going to build the image. I'm going to use some sort of made up name like this. Okay, so next step is to actually run run the Fast API app in Docker. So I'm going to give it a name, and I'm going to expose this port to this built image like this. Okay, so now it's running. So let's give this one a try in the browser. Localhost, and I think it's usually this URL to get to the Fast API. Sorry, not the Fast API, but Open API specification. So this super simplistic Fast API app only has one endpoint, which is the root call here. So if I run it, we will get back some sort of data. Hello world. So we got a Fast API app running in Docker from this Polylith project now. So let's go back to the code. What's actually happening here? So I'm going to shut this, close these other files down. So the project folder included some things here. They included a namespace package. So this is the way we include things into a project, and this specified from where we include it. So you see that it has this relative includes. This one is an import of the to bases, and these two is in the components folder. And if we have, I'm thinking about looking into the components. So we have this log, and we have this message, and this is a Python package, and a package can contain one or more modules, and a module in Python is a Python file. And in Polylith, it's a good idea to separate a package interface from the actual implementation, and that is done in this using the init.py file. So the log component exposes one function from this core module called getLogger. And currently in this super simplistic, silly demo example, that's all we have in this component. So it creates just a logger and adds handlers and formatters and returns it. And the same thing with the message component. We have an interface for it, which expose a function. You can choose what you want to make visible to the outside world. You could actually expose the entire core module if you would like. So it's up to you what you want to be visible to the outside world of this component. So, and the hello world thing here is just a function returning the string hello world. So these are the components, and the bases, if you remember, we included a base too, the greet API. And the greet API is actually the Fast API app. So we create a Fast API app like this, and we define the endpoint. And this base includes the message component, and it includes the logger, the log component, and the log function, like this. So with the logger, we create a new logger, and we can start log things. And from the message component, we actually return that. If you remember, the hello world function just returned the string hello world, and returning that one. And that's actually what we saw here. So this is the what we are returning from this function. Okay. So that's how these things connect. So you have a projects folder with with a project file and some infrastructure attached to it. And this is where you define where your actual source code is put. So basis is sort of the special components where you have your like endpoints or entry points for apps and things like that. And components are the small parts of your application, small parts that you combine into an app. So, and what I would recommend is that you don't actually do much more in the projects. You don't, when you develop, you should actually develop here, up here in the top folder, like this. And that's where the development folder comes in. So this is our playground. This is where we can experiment and try out our code, besides adding unit tests or integration tests. But this is where we can develop things and try them out before we actually use them. So you see, this is my module, david.py here. So I'm importing the log and the message, and I'm trying them out. So, and I really like the REPL driven way of developing things. So I can send the code into the REPL just to give it a try to see what's actually happening here, like this. What's in the data variable and how things work. So this is the way I prefer to work with Python and other languages that have this kind of REPL driven thing made possible. And the development part has its own project file. So you see, maybe you have noticed that there's a Py project in the root folder too. I'm going to close this before. Sorry, wrong key combination. So in the root folder, there's also a project file, and this is for development. And in this project file is where you add all the code. You add all components, all bases. And that means that you have, and you create a separate virtual environment. So you run Poetry shell and Poetry install in the root folder. That means that it will pick up all of your components and bases and put them in and have them available in the virtual environment, and of course all the dependencies too. That means that you can work in the top folder in your development and give all your components a try and experiment how you will combine them. So you can actually you can start writing and working with features before even thinking about how to deploy them, what kind of artifact you want to deploy. And then you can select, when you're going to build your project, you can select parts of the relevant parts of the packages section and what's relevant for the actual project in terms of development, dependencies. So that's kind of the main workflow in Polylith. So you are in the root folder, you develop things, you give them a try, and then you start constructing your projects. You can start the other way if you want, but I would recommend to just start coding, start writing components and experiment, and then when you think you have something that is good enough, you can think about how to deploy and what kind of artifact to build. One thing to think about is that I'm using MyPy, and I think that's a really good tool. But with this kind of structure, namespaces and packages, you will need to configure it in a special way. So it's not, you see it's 3 lines of code here, or configuration. So you tell MyPy where to find things, and that you use namespace packages, which is this style, and that is also this feature, explicit package bases, which means that it's not going to look for an init.py somewhere above the actual component. So it's going to expect an init.py down here, not at any of the top folders. And that's basically it. You're up and running with a Polylith repository.